Now let's do this. If we try to plot sepal.length, only that variable, and if you say type equal to L, then rather than points, you'll come up with a line structure. Let me show you that. There we go. It's a line. Rather than data points, you have lines, right? And if you do a bar plot, you would see a bar for each and every entry there in this way. This will also give you some kind of indication basically, but I believe bar plot does not give you much here. You can come up with a pie also. So you have iris dollar species. Here you have the species, right? And if you come up with table of species, let me select only that portion. It comes up with the table. It says that Setosa, you have 50 entries. You have 50 entries of versicolor and 50 entries of virginica. And you can do a pie chart of that. But I would say please do not use pie chart if you're trying to represent more than 2 categories. If you're trying to represent male, female, pass, fail, defective, not defective, then pie chart should work well. But greater than 2 categories, please do not use it. To know why, I request you to go through the Tableau tutorial. Histogram, anyways, we know that, but let me remove that. We have done enough of histograms. So let me do this. I'm trying to run a box plot on sepal length, and I wish to represent that in horizontal format. So if you run this, there we go. And there is something called as a rug. Rug will give you minor gradients on the scale. If I do a rug, and if it says side equal to 1, look at what it has done. It has tried to come up with smaller gradients here, right? And which will be, helpful for you to clearly try to, make out where you have the median, where you have the upper quartile, lower quartile, minimum value, so on and so forth. And we have a beautiful function called as par mf row. And whenever you have this mf row, right, it's about rows comma columns. So you'll have 3 rows and 2 columns. Let me show you on how it works. That's very beautiful basically. So I've run this. So from now on, the next 6 plots would appear here in this space. Let me increase that. So first one is sunflower plot. These are all sunflowers basically. So you have 1 plot here, 3 rows, remember, and 2 columns. So the second plot would be here with, it's just a plot, so it has taken the default circles there. If you run this box plot, it will appear here. A plot with line would appear here. A density plot appears here, and histogram would appear here. So we have 3 rows and 2 columns. If you have a scenario wherein you want to analyze multiple plots at one go, probably this makes sense. Maybe when you do your exploratory data analysis and when you want to create a report for your customer, I would suggest you to go with this kind of a plot wherein you have all the plots in one go, and then save it, and then you can draw a lot of inferences based on that. Okay. Now mf row 1, 2 would give you 1 row and 2 columns. So let me show you that. Here I've done a basic plot. I've tried to plot miles per gallon and cylinder, and I've given these additional attributes. The main title is example title. We have color in blue, so you have those circles, data points in blue color. We have given a label for x-axis and we have given a label for y-axis. Now the next plot that we're going to come up with would appear here because it's a one row and two columns. There we go. So we have one row and two columns here. And when it comes to the number of colors, R is amazing. Look at this. We have 657 different colors which are available. Right? We have 657 different colors which are available. And there is something interesting here, I think, with respect to gray color. Look at that. We have not 100 but 102 gray color. Here there is only 100. How can you say it's 102? Let me show you that. Within gray itself you have so many variants, right? You have gray 0, and then you have gray 1, 2, 3, 4. And GREY gray is different and GRAY gray is different. In that way, when it comes to the colors, R has, a plethora of colors available. Okay. One more variant of this function called par. If I say par color equal to, say, yellow, it would change the background color to yellow there. And now if I do this plot, look at the background color. And since MF row was 1, 2, it has retained that. 1, 2. Earlier we have run this. Right? But you can always do this. You can remove all the plots and then run these functions so that your box plot occupies the entire space. Let me remove this. All right.